All right, so we're looking at chapter 10, hypothesis testing. And today we're going to discuss the last and final step, which is the conclusion step for our hypothesis testing 5-step process. So I'm going to remind you about the p-value. So the p-value we talked about last week. The p-value is stands for probability. And the p-value is the probability that a sample will result in a statistic such as the one obtained. If the null is true. So let's talk about this. So we know what the p-value is, right? Because we calculated it last week. We talked about this p-value is the probability, right? It's the area under the curve and the tails. And we talked about how to interpret it and putting it into words, right? So it's the probability of getting like a second or a third or fourth sample resulting, so meaning an X bar or a P hat, as far away from the center as the first one, right? And that's all we're saying, that it's the probability that a sample result in a statistic. Remember, a statistic, that's just a piece of information from the sample. So that means this is my X bar or my P hat. That's what we're talking about here. Such as the one obtained, so the one from my first sample, if the null is true. So we're saying that the first sample was based on the center being the null, right? The center, mu naught or p naught, it's the center of my curve, that's the null. Everything is based on that, right? When I calculate my test statistic, I have to use the center. When I calculate the probability, I have to use the center. So we're saying if the center is true, right, then that's what we got for a probability. And the probability of getting another sample, so sample mean or sample proportion, that far away from that center. Okay? So the idea behind all of this, the idea of my conclusion is if the center is true, right, then my samples should be closer to that center, right? So if my center is not true, if maybe the center should not be the null, maybe it should be something smaller than the null or greater than the null, then I would have smaller probabilities, meaning my samples would be further from the center. It maybe would be less than if I have my center really should be smaller than the null. I'm going to draw this out for you. And I want to just write this conclusion for you here. And then I'm going to draw it out so you get an idea. So the conclusion, what we're going to do today is we're going to see if the p-value, my probability, is less than or equal to alpha. If it is, then it is unlikely that the null hypothesis is true. So if my probability is small, that means my test statistic was far from the center. My first sample is far from the null, far from the center. I'm going to have a small probability. And if it's small, it's probably going to be less than my alpha. Remember, that's my level of significance. That's that 5% or that 1%. And if it is smaller, then it's unlikely that the center really is the null. That's probably not true. That's the idea behind the hypothesis testing in the conclusion. It's a little difficult for our heads to wrap around that idea. And I don't want you to get overwhelmed with it. We have some time to make sure this makes sense to us. So I'm going to write out the conclusion step, what I expect from you in the write-up, and then I'm going to draw you a picture, and hopefully it will kind of pull it together a little bit. So when we're looking at our conclusion step, I actually only ask for 2 bullet points in this one. But there's multiple pieces of information that I actually look for. So the first bullet point, I know we're used to having 4 in each step. This one's going to have 2. So the first one is I'm going to ask myself a question. Is my p-value less than or equal to my alpha? Okay, that's my first question. I want you to remember that this right here, my less than or equal to, is always less than or equal to. This inequality does not change at all, okay? This is always a less than or equal to. So you're always comparing your p-value in the way we want to know, is it smaller than your level of significance, okay? And then I have 2 ways of answering this, right? So I can answer it with a yes or a no. So I can say, yes, it is less, or I'm going to answer with a no, it is not less than or equal to. Now, if we answer yes, okay, then we can reject our no. So we can say, if we said yes, okay, right here, yes, then we're saying we can reject our null. We're saying our null probably is not true. Or if we answer no, then we cannot reject our null hypothesis. So if we answer no, we cannot reject the null. So meaning if our p-value is not smaller than alpha, we cannot say that the center is different. We're going to say, okay, well, I guess maybe I shouldn't be saying this, right? I shouldn't be saying that the goal is true. So that's what we're looking at. So that's my first bullet point, okay? And then the second bullet point is what we call our conclusion statement. So here you're going to say at what level of significance, so at what alpha. So at the alpha percentage, okay, so let me just write this in here. So at the alpha percentage level of significance, we can say the sample now I'm going to say it does if I answered yes up here, or I'm going to say does not if I've answered no here. Provide sufficient evidence to say that, and now you will reword your goal here. So here you're going to type in your goal, which is support for your alternative hypothesis, right? So in this conclusion step, I have 2 pieces. I have 2 bullet points. I need to write p-value less than alpha, answer it, yes or no, right? And then I'm going to make one of these statements. So if I said yes, I'm going to say yes, we can reject the null. If I say no, we cannot reject the null. Then my second bullet point is at the 5% level of significance, the sample does provide sufficient evidence to say whatever my goal is, okay? And your goal, you already wrote really nice up in the population step, okay? So you already have that. You don't have to retype it. You can copy it and paste it from your population step, the very first step we looked at. Okay. All right, so let's take a look at what this looks like visually for us. I tell you guys all the time, I want you to draw these out, and I do. I want you to draw it out all of the time because I think it's so helpful. So if we have our curve here, okay, remember the center of my curve is that null, okay? And we want to see if we have support for our goal, which is our HA, and that's our sample, right? We want to know if our sample shows support, okay? So what I'm going to do is I'm going to put alpha on here. So alpha is probably somewhere right here. Remember, alpha is the level of significance. Okay. And alpha represents this area in this tail, right? So if it's 5%, that means I have 5% in this area. If it's 1%, it means I have 1% of area in the tail, right? So alpha moves based on whatever it is. If it's 1%, it's over here. If it's 10%, it's over here, right? 4%, maybe right here. A lot of times we look at the 5%. This is just a sketch, it's just a drawing. It doesn't matter where it's located on here, like what we're looking at, okay? Now, I want you to think about where our sample is if we're saying our p-value is yes, less than, okay? So if I'm saying yes, my p-value is less than alpha, that means the area under the curve is smaller, so it means I'm over here someplace to the right, okay? It would work if I'm on the left, it would just be to the left, it would be smaller, so I'm gonna draw it in here. So this would be for my HA, right? This is my sample. This will be where my test statistic is. This area is the p-value over here in the blue. And that would mean that it's less than. So that means I'm answering yes, right? When I say that the p-value is less than or equal to alpha, right? That's what we're looking at. That's where it would be located. Now, if I had a sample where the p-value is greater than alpha, that means I'm over here someplace, right? So this would mean I have my HA and my sample leaving my test statistic. My p-value is the probability for the area here, all in the red, all the way to the right of that. And this would be where I said no, that the p-value is not less than or equal to alpha, okay? And that's because it's greater than. I'd like you to see this visual. I think it's so helpful. So think about this. If I got a sample, right, and my test statistic left me here, right, and my p-value is all of this in the red, everything to the right, that means that my sample is closer to my center, right? If the probability is greater than alpha, it means it's closer to the center than alpha is. And that's saying that maybe the center is true, because if the center is true, shouldn't most of my samples be closer to the center, right? A lot of them should be close to the center. Remember the 2 standard deviation thing, right? 95% should be towards the center, okay? And maybe then my null would be true. So that would be the no, it's not. My sample does not provide evidence. I cannot reject the null, the center. Now on the other side, if my sample is far from my center, right? My test statistic, it's way over here. It leaves me with a p-value, an area in my tail that's smaller than my alpha, right? So you can see it. It's further away from the center than alpha, okay? In this case, I would say, well, geez, the sample is really far away from the center. And yes, that can happen from outliers or something, right? But what we're trying to show is if it's that far from the center, that it's less than my level of significance, then maybe the center is not true. And then that's where I say, yes, my p-value is less than alpha. I can reject the null as being my center. Maybe my center should be over here and my curve should be drawn in a different way. That's what we're saying. That's what the hypothesis test is about. I know it's hard for us to wrap our heads around it a little bit at first, but we'll get it. So I think this visual is so helpful. I want to go through the examples that we started the last couple classes, okay? And we're going to just complete the conclusion step, but I have to recall some information so we can use it. So this is, I'm going to say from last week, but it's really from like the last 2 weeks, right? And we're looking at the RIT students, and if they approve of the university admin. So let's just recall some information about this. So let's think, we have our null and our alternative. We need to have those in front of us. So remember, this is where the professor wants to prove that the proportion of RIT students is greater than 67%. So I wrote it in decimal form. And that means the null is less than or equal to 67%, my proportion. We found X, so the number of people that answered yes to be 62, N is 80, so out at 80. So P hat is equal to 62 divided by 80. We already did all this. I'm just recalling the information. Alpha, we said, was 5% 2 weeks ago. Last week, we calculated that z-test statistic. And we found it to be 1.9973. And remember, then we calculated a p-value equal to 0.0229. So that's all from last week, or 2.29%. So now this week, we're going to use that to find our conclusion. So my conclusion step, the first thing I'm going to say, is my p-value less than or equal to my alpha? I'm going to ask myself the question. I'm going to fill it in with numbers because I think it helps us. So everything I write here is what I expect to see from you guys. My p-value is 0.0229. Is it less than or equal to my alpha, which we said is 5%, or 0.05? So if you have a hard time comparing decimals, then you write them as percentages. Write this as 5% and write it as 2.29%, or just view it that way. So here I'm going to answer yes. So yes, we can reject my null. Okay, so that's the statement I'm looking for. So is this true? Yes. If it's true, then it's a can reject the null. It's going to be all positives. Yes, I can. And then down here in my conclusion statement, it does. So I'm going to say at the level of significance, which here 5%, write as a percentage, 5% level of significance. Guys, I always write it the same way, and you are welcome to use my template statement. So at the 5% level of significance, our sample does. Now I'm answering this with a does because I said yes here. I can reject the null, does support. Okay, so our sample does provide support. Now I want to write my HA here, right? And I already have it. It's just 2 weeks ago we wrote our goal. So you would just copy and paste your goal in here. My goal is always about HA, right? So it's to say that the population proportion of RIT students that support the admin is greater than 67%. So that's what I'm gonna write. So my sample does provide support to say that the population proportion of RIT students who approve of the university's admin is greater than 67%. So remember, like I mentioned before, when you make the goal and you write it with a percentage here for these proportions, it makes more sense to any reader. And you can just write 0.67 for me. I will get what you mean. But just for anyone reading the statement, the 67% makes more sense than the 0.67, but for me, write it anyway. So what I'm looking for in here, I want you to include at the 5%. I need to see if it does or does not provide evidence, and I need to see your goal here. So I need all of this whole statement. This is your goal. Okay? You can write the statement any way you want. I'm giving you a template. I want you to feel free to use the template. It's very simple. I want you to notice all positives. Yes, can, does provide support. Right? And if it was a no, it would be no, cannot, does not. It's all negatives. I try to set it up so it's very simple for us to remember. Okay. Any questions on that one? So we're going to look at the other example real quick and complete that as well. All right. So let's take a look at the other example from last week. Remember, this is the apples, and we're looking at the weight of the apples. So let's recall from last week, the null and the alternative. The alternative, we're talking about weight of apples, and this is where the store manager wants to show that the mean weight, so the average weight of the apples in a store was less than the 6 ounces. So that means the null is greater than or equal to the 6 ounces. Took a sample of 61 apples, found the sample mean to be 5.6, the standard deviation to be 0.1. Alpha, again, is 0.05 or 5%. Now here we have that t-test statistic from last week. Remember, we found it to be negative 31.24. It's really far away. And that led us to get a p-value of just about 0. But remember, we don't ever report 0. We say very small. Okay. So now with this information, let's go ahead and complete the conclusion step. So here, I'm going to say, is the p-value less than or equal to my alpha? It's always less than or equal to. It has nothing to do with any of these inequalities up here. This is always less than or equal to. So I'm going to say, is very small less than or equal to 0.05? Well, yes, it is. Yes, we can reject the null hypothesis. Okay. So if I can reject my null hypothesis, that means, yes, I do have evidence to support my goal. So now I just want to write that out. So at the 5% again, because our alpha was 5% up here, that's what we compared our p-value to. The level of significance our sample does, because I said yes, show support. Now I'm going to just copy and paste my goal in here when I'm using my computer. And my goal is, remember, for my HA to be true, so that the population mean weight of the apples is less than 6 ounces. So to show support, to say that the population mean weight of the apples in his store is less than 6 ounces. Okay, so here we're looking at where we said yes, Henry Jett does show support. You always want to include the level of significance here. You want to include if it does or does not show support, and you want to include your goal statement down here. This is your statement about your HA. That's what I look for. So I know there's only 2 bullet points, but I really look for 4 things. I look for this answer, if it's a yes or a no, and if you can or cannot reject. I'm looking for my level of significance, if I do or do not have support, and your goal down here. Okay. So I know there's only 2 bullet points in this one, but I still look for 4 pieces of information, or maybe even a little more. The conclusion step goes really quickly because we have done all the calculations. You're just seeing if something is less than, if it's smaller than, right? You should already have your drawing done by now if you did a drawing. And then you just have one statement to make here.